help or support each other is now, because in the example, we may not even know who you are sitting next to. You don't know the person you're sitting next to is even know better than you. That's just true. So, and you may not even have the opportunity to actually care on someone or anything. So we can just solve this. So now, number one, let's start with the number one question. He said that a die, a die now, a die when you a die when that when you are if you play Ludo, right? You see that die that they used to toast it. So that die it actually have the total outcome on that die is actually six. The highest is six. That's so now the question said a die is rolled and a coin is toast. Now explain in detail using HT symbolic function of the die and the probability that the die shown and the probability that the die is shown and shows an odd number and the coin shows a head. If you have a coin either has a tail or a head. And then if you a die has about the total number of six, either you can get the one, you can get the two, you can get it like that. So now the first question they ask you is what? Explain in detail using symbolic function of the die and the probability that the die shows on. So I'll start here. So once again, please, just to confirm, you can see my screen, Abby.
Yes, I can.
Okay.
Yeah, we can see it. Go ahead.
So we have that first thing with the access said like to show this, right? They say explain in detail using the HT symbolic function of a die in a probability that the head that the dash that the dash shows an odd number and then the coin shows a head. So it's very simple. So we just start. And if you look at it now, this question has two events: a die and the coin. That independent. They are not like in fact they are not similar events. These are two separate events, right? They are independent events. Because if you look at it, a die is rolled and a coin is toast. Understand? So these are two different stuff here. So, but then let's do the answering of the question that they asked. So let's look at the outcome. First of all, we can have the first question they asked us here. That probability, the HT are symbolic function. So, so let's just say the meaning of so that you just understand what this means. Now, what this means is like for it just mean a they are just talking about this one. This is a coin, right? We're just talking about a coin, and then the coin is either having a head or a tail. A coin, like a coin that we use. So it either has that. So So when you see something like this, a HT symbolic something, what that means is simply represent the possible outcome of a coin. Do you understand? That's what it means. Now and then it just like so when for this one that is a die, right? A die is for a for a die, the possible outcome. When you toss it, when you roll a die, the possible outcome. So here you can see now what this is giving to you now. The possible outcome of a coin now is one and two. They're just two. That is one and two. So either you have this one. So it's one, two. But this one now you have one, two, three, four, five, and six. This is for and six. So this is for a die and this is for a cone. So this is actually this is just the representation of what it means by this. You understand? That's just what it means by that one. So and then if you want to now do this, right, for this head now, if I toss a coin, either I will have this, I may have head, either I will have this, or I will have this, or I will have. So the questions show this and the coin shows ahead. So now we in solving the question now, just to solve this question, again, the next thing you need to do on that particular that's we're still on question 1A, right? And then we'll just continue from there. So we'll then look at kind of sample, understand. So if you say okay, you want to solve it, they'll have like what is sample here. And then for a die, just like I said, I have written it here. The possible outcome that you're going to see here is this guy. Is this one to six? These are the possible outcome that you're going to have. And then for the coin, you're going to have uh, head and then tail. So the question we need to find said, now they said explain in detail which what we are doing. So he said that the function of the die, that the probability that the die shows an odd number. Now, what is an odd number, right? So, if you look at this number, say in a die, what you have here now, we have fix this guy first. So, what you have here, you have one, two, three, four, five, six. Now, inside this number now, which are how many numbers are odd numbers? It's one, right? I have one and three and 5. These are odd numbers. So this is what it is looking for. They're looking for this. So the possible the now inside this, when you draw this die now, remember the total outcome of the die is six, one to six. But now, based on the question they're asking that what is the probability? What are the chances that you have odd numbers inside one to six? That means it's three times. That means what you're going to do here now is you just write uh, the answer of this one is going to be three times. That's three is equals to three, right? So now we have the three now. three. Let me just put it here just to make it three outcomes. So this 1 to 6 is a total number of outcomes that you get. You understand in that. Now the other question here asks that, okay, so what's the probability that the die shown is an odd number, and what is the probability that a coin shown is a head? So this one, and so this was our event B, A, and then let's look at our event B, which is event B now is it's our coin. Let's just say event A, it's our die. So this one now, what is the probability that what is the coin that will show is the head? So this one will have. So all this we just present this. So we have the head, right? So the head we can just maybe just put H or so. And then we'll move on. So now we now need to solve it in doing the math. We need to do some mathematics here. And why are we doing the math? So, because if you look at the requirement, the events of the requirement, you said that shows an odd number and coin shows a head. That's the probability that you are solving. So you need to do a probability formula that said this is probability is A intersect B. So what I'm writing here is not N, this is intersect, right? Something like this. You understand? So that's the formula. So the formula now is equals to you are looking at the favorable outcome divided by this is now divide by division by total outcome. So now in this the first question, which is the die, what was the outcome we are looking for? It's three, right? Are we following? And you are we understanding?
Following, but I do not understand.
Okay, you're following, but you don't understand. Okay. Who again? Who is following and is he understanding? I know because like one person said she follows but she don't understand. So I kind of maybe I want to now start over again. I don't know when she joined, but I'll try to explain from the question. Then now continue from there. Ah, but is anybody following me and understanding at the same time?
Hello. Okay, I'm also following, but I didn't understand from that how you did that symbolic presentation.
Okay. How I'm trying to open across material and ask you guys a question. This is 806. Perfect. So for probability, that's module what? Module two. Module two we have probability here. So okay, have any of you read this material to this level? I believe so. So I just want to show you something. That should be study session two. Two, yeah, probability. So we are looking at probability. Yeah, at least I just want to give a like a brush up of what the probability means. So now the meaning of probability. So, so everything down a probability is a quantitative measure of uncertainty, right? A number that a number that conveys the strength of our belief in the occurrence of an uncertain event. So likely something that we are not sure of this thing happening, but we it may happen, it may not happen. Sure, you can understand. Just like if I throw a die now, right, or if I throw a coin up, when they want to play a match now, let's say this, that is a very probability is a very good sampling techniques, right? Because it is very unbiased. Just like if I have a coin here, let's say I want to continue this class or not, I'll say, okay, if I throw a coin and if it is some person that say the class should continue, should choose the head, and the people that say the class should not continue should choose the tail. And if I throw this coin and then if I have the tail, that means class is over. That is what probability is talking about. It's very simple. But now there are so many events that happen. Statistics. There are so many. So these are just. In fact, this example we are solving is very practical. So I want to just understand the question. Let's understand the question very well. Then we'll now continue solving like that. And then, so this is probability has some computational rules, and that is the one I was trying to use there. So now look at it. Look at it here. This is number one. Now, if event A and B are two mutual independent events, then A is equals to. So this is a multiplication probability. This is a multiplication what rule. So we have A B is equals to A. That is a probability of A times probability of B. You understand? If they are mutually what? Independent. So now another event, which is another example is B. Probability of A O. Now this is for A. We have A O and A and is like. So A is now O is equals to probability of A plus probability of B minus probability of AB. So AB is that what probability of AB means multiplication. So this is like addition. You add up this and then you minus it with one after you multiply this. So if A and B are two mutually what inclusive event. So
Hello.
this one.
Sorry to pause you.
mm,
Sorry, I just wanted to ask quickly. Will they give us these formulas in the exam? I mean, we have to cram them.
They will not give you the formulas in the exam. It's just something they
Ah,
believe that you should have understanding. You should know. So, okay, like example now, look at the example of the probability here. Say a student tosses a coin once. What is the probability that the head will appear? It's just 1/2 because the total outcome of a coin is two. And if I toss
mm,
a coin, and I'm expecting what is the probability that I will get a head? Is 1/2. What is the probability that I will
yeah,
get a tail? Is also 1/2. Do you understand?
yeah,
But
that's
now, in a situation whereby now this is just I toss the coin once. Now I may have different events. So inside I can decide to toss this coin 5 times. So that means the first one, what is the probability that I will get the first one? So the first one that is A, the second one B, I can have a C, D. That is when you now start making use of these formulas that you're seeing here. So let's say this one, I
okay.
posted it just once. That means it's straightforward, 1/2. I toast it again. That's another event. That means, okay, so now what is the probability that I will still get the head? So what I will do now, I will add the two head, add 1/2 divided by what? This. So I will now have 1/2 plus 1 over what? 2. That means the so that's just what it means. So let me so all these things are
Independent and mutually exclusive events.
sorry, I didn't get that.
The meaning of mutually independent event and mutually exclusive event.
Sorry, did someone hear what she said? Hello? But and so the person asked, I didn't get the question. I'm trying to, I don't know that someone heard the person. They can let me hear. Hello? Like my mic is. Hello?
We can hear you.
Okay, so someone was asking me a question. I didn't hear. I want to know whether I I got the question very well. I was sharing a PC. So are you asking for the person that asked the question? Are you asking the meaning of some mutually independent event and mutually exclusive event? Okay. Okay. Apart from that person, I think maybe the person is no longer in the meeting on the call. Okay, but the rest of you that are here, do you understand the difference between these two? When he said an event, two events are mutually independent events and two events are mutually exclusive events. Do you understand that? All of you that here now.
No, please.
Okay. So now let's start with the independent event, right? When we talk about two events are mutually independent, that is, we are talking about if the occurrence of that event, or that is of one event, does not affect the occurrence of another one. Now, all this event is supposed to occur, but then independently, that means if event A happened, right, it's not going to affect event B from happening. That's what it means. Two events are mutually independent. Two events are mutually independent. That's what it means, right? In simple term, let's all say in simple term now, you can say that you want to this event, you want to know that one event has happened. What happened to one event does not change the probability of another one. Do you understand? So that is why in this place now, these are the formulas that actually works in this. So in here we have multiplication or product rule and the additional rule. For events that are two mutually independent, you have this. Now, when you come to the two mutually exclusive events, you also have additional rule. Now, when do you understand that a question is this or that is how the question comes in, and then we'll understand it. Don't worry. Let me just talk about the exclusive event. Now, for this one, when you said A and B are two mutually exclusive events, you are saying that these events are mutually exclusive. That is, if they cannot happen, that means this event they cannot happen at the same time. Do you understand? Two of them cannot happen at the same time. So, like from the example of what you are doing now, can when you're talking about a die and a coin, are there two mutually independent events or two mutually exclusive events? Hmm? So, okay. Now, example, very simple example here that you can say is if I toss a die, if I toss a coin, if I toss a coin now, can I have a head and a tail at the same time? Is it
No.
possible?
No, both
It is not
yes,
possible, right?
mutually
So, yes, so it means you cannot get a head and a tail at the same time in one toss. That means this event are what? Two, they are mutually what? Exclusive. I can't have them at the same time. Okay. So let me go back to should we go back to our past question paper and then try to see how we can solve that? I will explain the question again.
Yes, please.
Okay. So I've deleted everything here and I want to start afresh. So this is a past question paper that I have. And then it's 2022 January. It's January because past question paper. So they're also in January. Bad news. Okay. So we have two events here, right? And the first one is the a die. So if I you say a die is rolled and a coin is tossed. Now explain in detail using symbolic function of a die and the probability that the die shows an odd number, right? The die shows an odd number and the coin shows a head, right? So we want to start solving it now. So if you look at it, the same, what they actually here, like in this question, the first thing is explain in detail using the HT symbolic function of the die and the probability that the die shows an odd number and then the coin shows uh, a head. So now, if you look at it now, like I said, a die, you know a die now, something that if you play Ludo, you should know that. So we have two events, right? We have two events here. Number one, which is we can say A is an event, and then we have B, also an event. So we have A and B. B is talking about a die, and then the B uh, is talking about uh, store. So now in step two, so this is just the event that I'm talking about. I'm just looking at this. So what you're looking at, so you can just say, okay, since the question is this, you can just say A, it's actually a die, and then a die is uh, just say a die is, and then B is a coin. A coin is toast, right? So now, and we're looking at this, right? This, if you look at this now, you can see that these are, this should, or in fact, these are independent event. Right? These are independent events. So we, for us to solve the next thing, the next step we need to do, we need to get our samples or our sample space, or something like a sample space. So the next thing here now, we first of all we're looking at our event A. Event A, we're talking about a die. And now, what are the possible outcomes in a die if you actually roll a die? Remember, a possible outcome is six, total of six. So I have six. So what I have one, two, three. So that means if I toss a coin, if I roll a die now, I can either get one, I can either get two, I can either get three, I can either get four, I can either five or six. That is what it means. I have three, I have four, I have five, and I have six. Okay. So for event B, which is our thing, right? So this one is what we can either have a head or either have a head or we can either have it. That's what I mean. So we have either a head or a tail. We can have it. So this is one one. This is one one one. So the total of this is going to be like what? Six. It's going to be a total of what? Two. So one, two. This one, 1, 2, 3, 4, 5, 6. So the total of outcome that you get here is what six. But the six here, these are just outcome that you get in when you roll it die. So this one now we have what? For this one we're going to have, so let's just say the total this thing that we have here is what? Six. Sorry, this is six. Let me make it bold. Then this one, what we have total is now two. That's two. So now remember, now what we have here now, right? This event. So what is going to be our total outcome here in this event? These two of them now. So the two events here, like I said, they are what? Independent what? Event. So what it means is like, let's assume now we want to apply this formula, the probability formula that I show you guys here, right? That two independent event. That means A event is going to multiply by what? B event. That's what we're going to get here. This is what we're going to use this. Now remember, what is the total outcome in an A event? Is six. What is the other one in B event? Is what? Two. So what we're going to do now is we're now going to multiply A and B together so that it will give us the possible outcome. Do you understand? So that means we are going to do this now. Uh, our total outcome here now is now equals to 6. So we are looking at, we want to multiply the probability of A and B. A is what? 6 and B is what? 2. So that means this is going to be 6 equals to, let me just write this way, 6 times 2. Then this will give us 6 times 2. Then it's 12. That means this is our total outcome, which is 12. So now, the next question that we have there to solve, right? We have another question to solve here. Now, after we have done this now, so we want to find the probability that the die shows an odd number. So now we have this now. In this a die here, we have 1, 2, 3 to 6, right? So within this number, we have one is an odd number, three is an odd number, and five. Because if you look at
Hello,
two,
can I ask a question?
okay,
Yeah, I think both the die and the coin are mutually exclusive, right? So if we follow the probability rule,
mm,
that should be addition. So why the multiplication?
they are not they are not mutually
They are,
exclusive.
are they not mutually exclusive?
No, there are two independent events. I can run my die and I can roll my die, I can be tossing my coin. They are two different
Okay,
things. They
okay,
are events
I get
that
you there.
cannot happen at the same time. Just like if I roll a die now, I cannot have a coin, I cannot have a three and four at the same time. These are mutually
Okay,
exclusive events.
I understand. Thanks. Thank you.
Mhm.
Get it now.
So you the total outcome of these two events now is what 12. So now the question of now we need to get an odd number. So how many are we going to have here? This is one, uh, three, and five. They are odd numbers. So that means the outcome of odd number is now three. That's three. We have three. Simple. So that means since like my system is slow, let me plug it. Oh, then we have to remove my. Then I have to plug it. Okay, sorry. Can you still hear me? Actually, change my mic. Okay, thanks. So now, what is the probability that the die that will show is going to be an odd number? It's three. That's one, two, three. Three of them. There are three chances that you have odd numbers when you roll a die. You have three, five, and one. These are odd numbers. So that means the answer there is going to be oh. So we are looking at event A, and then we are looking at let me just say die shows odd number. So what we have now, and we can just say the odd numbers are this one, three, and what five. That means we have a total of this is three. So that is three that we have. See? So that means it's three. I want to make it bold. So we now have three. Okay. So that means what is now going to be our answer? So the formula now for us to solve this, we are looking at uh, the formula is just very simple. Is what is the formula for probability? Is the total of is let's say we are looking at the four variable outcome divided by the total outcome. And our total outcome here is six. It's 12 because of this is 12. So we now have to say, okay, this answer is going to be 3 divided by 12. And then we can say it's giving me as date for the first. I'm going to general 3 divided by x. And just add something. This is going to be 3 divided by 12. Then it will give me 3 divided by 12. And 3 divided by 12 is going to be 3 divided by 12. Then we have 0.5. So that's the answer. So that means the answer for that one is what? 0.5. Are we together? Did you guys don't understand? That was the answer for that question. Yes. Mm, okay. So now those events are so now, now remember we saw. Okay, now, okay, let me do this in a way that can answer that question you just asked. Right? Let's do this way. And it's going to be more uh kind of tedious anyways, but let's just do it. So let's say I have this. Mm, when we're talking about this event now, we have two events here. This if I have but the question now, this one here, what we have here now. Look at this event here, one, two, three, four. uh 1 2 3 4 5 6. Yeah, this is the event A and this event B. So I want to represent this in a way that it will make you understand that question. So I have when I have one, two, when I have one here, that means I have one and I have head. I'll have two and I will have two and I will have head. And I will have it when I have it two. And when I have a three, I'll have a head. That is what this event means. If I have a four, I have a head too. I have a head. And when I have five, so the same thing. If I have one, I have head. It's two, it's three, it's six. Okay, so now that question is one question. And what they put and there, they're talking about two events. That and there, it's a kind of that and was from this question. It was this and he said if and are mutually independent event, then use this formula to the product rule. Or now this is for and this is for all. Now if the question there was oh, I'm not going to use this formula. I want to pay attention. I was not going to use this formula if the probab if this thing was the question there was oh, let's go back to this question so that you I'll not come back to that. Then this event are two events, independent event. And then the formula here it's now this and you have to pay attention to this combination like and or you need to understand the meaning. When they say and, right, these events are happening independently at the same time. So even though I have this coin, I have my coin is happening. I'm going to have only one. I'm going to have a head and a tail. So whenever all this, the total outcome of this event is six. This head supposed to appear six times. This happens six times. This happens six times. This six times does one, two, three to just be at the same time. Because whenever this happen too, or they are independently happening at the same time. That's what that means. So I'm just trying to illustrate this in this diagram so that I will explain this better for you. So for us to answer that, that is why when we come here, we use our multiplication sign to get 12. If I was going on an independent event, like and it's just an individual event, I cannot use 12 to say it's the outcome of this. This 12 was for the two of them when I use the and condition to get the multiplication probability to get 12 as outcome. So now you have already the question did not ask you now, when do you get odd numbers and also get a head? It's three times. Look at it. If I have this, I have head. If I have this head. If I have this, I have head. If I have this, I have head. So this already answered this question. So by the time you get 3 all over 12, it will not give you this. This 12 already captured this guy in this event of B. That's what it means. Just three. So because if I take this now, this, 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 that's what I have. So it's three. This one, two, three. Then this three divided by 12. It will now give me 0.5. Did you understand or you still confused? Yes, I can hear you. Yes. Now if exactly by three, the same thing. By the time you finish it and add the thing together, you still give me the same answer. It's just the same thing. We have done this. If we are doing it by six divided by the event, which is three, and then one divided by this, it will now one by the time we add it up in the probability rule, then it will still give us the same 0.25. That was the same thing. But then the 12 now captured everything for us. Okay, so that is number one. That is the A part of the question. Now we still have another question, which is the probability. Now this one said the number B part of the question said the he said that the the blood groups of 200 people is distributed as follows. Now 50 have type A, and 65 have type B, and 70 blood have O blood type, and then 15 have AB blood. Now, if a person from this group is selected at random, what is the probability that this person has O blood type? A very simple question, but very, very probable. It have to you have to reason it. If you even reason it very well, you answer the question. Alright. Now, look at it. We are saying, so let's first of all look at the total outcome, which is 200. Yeah. The total outcome here, the total number of people, total people, total people is 200, right? 200. So The total people is 200. And the question said the the 200 people, the 200 people blood test is distributed. 50 people have what A. So now let's 50 people have A, and 50 have A, and then 65 has B, and then so let's say A is 50. Yup, 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 yup. So that's B. B they have 65. The B they have 65. 65, and then O they have 70. And then 15, which is AB, which is 15. Okay? So or 70. So now the question is this one, the question is very simple. You don't have to solve too much. They're asking you that what is the probability that the person has blood group what? O. So what is O? O is 70, right? Very simple. So what is the probability? The probability is the number of people with O divided by the total number of people. So all you need to do is just to say the answer now is the probability of O, which is this, is now equals to, right? Is now equals to, let me write the formula, equals to uh number with O divided by total number of people. Total number people. So in simple thing, that means this formula will not work. Let me just put underscore so that you know that it's equals to. So the next what you now need to do now is equals to, what's the answer? This is, we now have 70 divided by 200, and that is your answer, 0.35. You're done. That's all. This one not simple enough. That was like a bonus question for you. So yeah, that is number one. A and B, you have solved it. That's all. So you can just say, you want to just say the probability of, so that the man will know that this person knows this very well. Uh, the probability of or the probability that a random, what did they say? They say what is the probability that the person, okay, if a person from this group is select at random, what is the probability that the person has O blood type? So I will now say the probability that a randomly selected person has O blood type is what? 0.35. And then I will now tell the man that full stop. And that means I've solved this question. So that means that is number one, A and B. You can see A and B is solved. I know if you see this question like this in exam, God, you solve it. So we have number two. This 802 have a lot of calculations for real. Like, you just calculation. All the past question people I'm seeing just for calculations. I don't even know why. Okay. So should we try number? Should we do number two? Should we try number two? Okay, we'll try number two then. Number two kind of okay. Number two says in a small business firm, two